to introduce my teammate.
Assalamualaikum and hi everyone. My name is Nurin Arisha binti Muhammad Azli.
Assalamualaikum and good morning. My name is Putuna Farhana Elisha binti Azhar.
Hi, I'm Alisha Nadira binti Azizi.
We also do our meeting on 15 November 2024 at 8 p.m. until 10 p.m. at UTHM Residential College Cafeteria.
The objective for the report is identify how to use formula, sequence and series. As you know, sequence and series are different. They different into in term formula. Okay, for sequence and series are divided into two, namely arithmetic and geometry. Okay, besides able to develop thinking skills to solve a problem. Okay, and the last one is able to determine how much energy is used for this project.
So I'm going to talk about Fila table. So F is stand for fact. We need to know how many panels will be installation for finish this project. And second, we need to know how to calculate the daily energy generation. And third, we need to know how many of installation are needed to generate energy. And fourth, we need to know the total cost of material for a project over 6 years. Okay, next, I is stand for ideas. First one, apply the formula for arithmetic sequences to determine panels installation on specific day and total the panels installed. Second, use the total panels installation to calculate the energy generation. And third, solve the inequalities to determine the number of the days needed to achieve 500 kilowatt per a day. Okay, L is stand for learning issue. How can we calculate the total number of panels installed using the arithmetic series formula? And second, what formula determines the panels installed on a specific day in arithmetic progression? Third, how can we model the daily workload growth using geometric sequences? And fourth, how can we calculate the cumulative productivity growth over multiple years using a percentage growth formula? Okay, last one, A is stand for action plan or resources needed. Okay, number one, we can review the geometric sequences formula and how to apply information into the formula. Second, take a look the previous or past project assignment and to make sure that we can do a comparison. And third, we can refer to references book or blogs on the topic of three algebra, namely sequences and series. Fourth, the last one, we can prepare another material such as a calculator to calculate the answer. That's all from me.
Calculating the number of panel installed. Panel installed on day 15. We are working with an arithmetic sequence where the first term A equal to 12, the common difference D equal to 4. We are finding the 15th term N equal to 15. The formula for the term of an arithmetic sequence is A N equal to A plus bracket N minus 1D. Substitute the value A 15 equal to 12 plus bracket 15 minus 1 bracket 4. Simplify. A 15 equal to 12 plus 56 equal to 68. The number of panels installed on day 5 is 68 panels. total panel installed in 20 days. We use the formula for the sum of the first n term of an arithmetic sequence. Sn equal to n divided 2 bracket 2 a plus bracket n minus 1 d. Here, n equal to 20, a equal to 12, d equal to 4. Substitute the value as 20 equal to 20 divided 2 bracket 2 bracket 12 plus bracket 20 minus 1 bracket 4. Simplify as 20 equal to 10 bracket 24.
Common ratio. I get what I get for common ratio is 1.1, 1.10 like that, and then I just plus with the second number 100 plus 10, I get 110. 110 multiply 10%, and I got 11. And same for the next steps. And conclusion is, if we want to know day 2, day 3, and day 4, we must 100 multiply 1.10, and we got 100, and the same for the next step with the same ratio. But this is how I got the common ratio. And it starts to complete in 30 minutes. So we just get to multiply 1 to 3.1 task, multiply 30 minutes, and we got 3993 minutes. So we need to find in hours, so we must convert to hour. 3993 divided by 60, and we got 66.55 hour, which means this is overall, this is total time for complete task in 4 days. But when I calculate the team capacity, engineer 5% working per day, 8 hour, 5% divided multiply 8 hours, we got 40 hours. So which means is below, is 66.55 is greater than 40 hours. So which what can I summarize is the team can complete the workload in a single day.
Okay, now it's my turn to explain about task 3. For question 1, I use geometric formula. The formula is AR exponent n minus 1. Okay, the information that I have are A 100, are 10% plus 1. Why I said 10% plus 1? Because it increase 10% for each for 1 year. Okay, so every year it increase 10%. Okay, and I have n fifth. Okay, so just put all information in formula. Okay, for question 2, I use formula series. Okay, arithmetic formula. The formula is A bracket 1 minus R exponent n divide 1 minus R. Just put all information that we have in formula.
Task 1 is about a solar panel installation project that follow an arithmetic progression, starting with 12 panels on day 1 and increasing by 4 panels daily. These are for the numbers of panels installed on day 15, the total number of panels over 20 days, the energy generated after 12 days, 1.5 kilowatts per panel, and the day needed to generate at least 500 kilowatts per day. Task 2. Deal with a robotic project where tasks increase exponentially by 10% daily. Starting with 100 tasks on day 1, is required calculating tasks for day 1 to 4, expressing the growth as a geometric sequence with a formula for any day, and checking if a team can complete their 4 workload under specific conditions. Task 3. Explore employee productivity growth, where productivity increased by 10% annually from a base